Hello students, welcome to all of you in SAM Alchemy classes. In Hello Alkanes and Hello Arenes, we have discussed about nucleophilic substitution reactions of OH group by RO group by RCOO minus. Nucleophilic substitution is continued. So in this next we will discuss a reaction with cyanide group. So in cyanide group, the reaction will be a reaction with potassium cyanide. A reaction with potassium cyanide KCN. So when alkyl halide RX may be methyl, ethyl, propyl and so on, and halide chlorine, fluorine, bromine, iodine now reacts with KCN. Here the cyano displaces X, chloride, bromide, iodide, जो भी इससे अटैच है उसको CN डिस्प्लेस करेगी, फॉर्मेशन ऑफ RCN प्लस KX. यहाँ पर साइनाइड ग्रुप का फॉर्मेशन हो जाता है लाइक CH3Cl reacts with potassium cyanide KCN. The CN displaces chlorine, formation of CH3CN with elimination of KCl. This is called ethane nitrile. Nomenclature में इसके रूल्स को डिस्कस कर चुके हैं. Ethane nitrile is formed if we get C2H5Cl reacts with potassium cyanide, then C2H5Cl with KCl. This is called propane nitrile. Next is why this potassium cyanide KCN when reacts with alkyl halides gives cyano, means this CN get attached with this carbon. So here, since we know nature of CN, cyanide is the C triple bond N, negative here. So here the C, next resonating structure, it takes electrons, so it becomes C negative charge double bond N with lone pair. This is ambident ligand. Ambident in nature. What is ambident? Ambident nucleophiles are those that have two donor atom. जिनमें टू डोनर एटम प्रेजेंट होते हैं वो एम्बीडेंट न्यूक्लियोफाइल और एम्बीडेंट लिगेंड्स होते हैं. सिंस यहाँ पर कार्बन भी अटैच हो सकता है, नाइट्रोजन भी अटैच हो सकता है, दोनों साइड से अटैचमेंट हो सकता है, दैट्स वाई इस न्यूक्लियोफाइल को कहेंगे ambident nucleophiles. So what are ambident nucleophiles? Those nucleophiles that may attach from two sides or that contains two donor atoms are ambident nucleophile, and cyanide belongs to the category of ambident nucleophile. Here in cyanide case, carbon attached with the alkyl. Why? Because potassium cyanide is KCN is highly ionic in nature. Highly ionic in nature. ये ionic nature का होता है because potassium belongs to first group. Strong electropositive in nature. Periodic table में पढ़ चुके हैं. Strong electropositive का होता है because potassium is alkali metal. All the alkali metals are highest electropositive in a particular period. किसी एक particular period में Alkali metals strongest electropositive होते हैं. That's why preferably this KCN bond is highly ionic in nature. So first condition, due to highly ionic nature of potassium cyanide, and second thing, carbon bond is more stronger than carbon nitrogen bond. This is stronger than carbon nitrogen bonds to give the stability of the molecule. That's why when potassium cyanide reacts with alkyl halides, gives cyano product, and the cyanide attach with the carbon side. So if the question arises, why potassium cyanide gives nitrile, that is the carbon option attached with the alkyl. So answer will be, since potassium cyanide is highly ionic in nature and carbon bond is more stronger than carbon nitrogen bond, that's why potassium cyanide when reacts with alkyl halides gives cyanide product. Next is reaction with AgCN. Reaction with AgCN, potash silver cyanide. Silver cyanide reacts with Rx with AgCN, formation of RNC with AgX. Isocyanide is formed, also called as carbylamine. In IUPAC name, carbylamine, and this is alkyl, so name will be alkyl carbylamine, and its carbon is not included in the longest carbon chain. ये रूल्स में डिस्कस कर चुके हैं. Like this CH3Cl reacts with silver cyanide, then formation of CH3NC with elimination of AgCl. So the product formed is methyl carbylamine. So again the question arises, when potassium cyanide reacts with alkyl halide gives cyanide, while reaction of silver cyanide with alkyl halide gives isocyanide or carbylamine. Why? तो पोटेशियम साइनाइड का एक्सप्लेनेशन तो डिस्कस कर चुके हैं. इट इज ड्यू टू हाईली इलेक्ट्रोपॉजिटिव नेचर, हाईली आयनिक नेचर ऑफ KCN, एंड कार्बन बॉन्ड इज स्ट्रॉन्गर देन कार्बन nitrogen bond. So in AgCN, since this silver belongs to D block elements and this silver is very less electropositive than पोटेशियम के कंपैरिजन में बहुत ही कम इलेक्ट्रोपॉजिटिव होती है. That's why AgCN bond is covalent in nature. Due to covalent nature, this carbon is not free to get attached, while due to higher electron density at this nitrogen, it donates the electron towards alkyl and they make a bond with the alkyl. I repeat the explanation. AgCN is covalent in nature. It is very less electropositive as compared to potassium. That's why due to this covalent bond, carbon is not free to get attached, and here in nitrogen, due to availability of lone pair of electrons due to higher electron density, this nitrogen is free to get attached with the alkyl. That's why AgCN gives carbylamine, while potassium cyanide gives cyano groups. Next, reaction with potassium nitrite. Reaction with potassium nitrite KNO2 Rx reacts with KNO2 and gives RONO with KX. और इसको ऐसे भी लिख सकते हैं RH alkyl halide reacts with K plus O single bond N double bond O with lone pairs. Arrow RONO with KX. Nitrite are obtained. Nitrite. This is alkyl nitrite. Alkyl nitrite is obtained. So question: when potassium nitrite reacts with alkyl halides, alkyl nitrite are obtained. Why? Because this bond is ionic in nature, so it forms NO2 negative. This negative charge is present on oxygen. Why? Because oxygen is more electronegative than nitrogen. That's why, due to ionic nature and higher electron density at this oxygen, it is free to get attached with the alkyl, so nitrite are formed. I repeat the explanation. When potassium nitrite reacts with alkyl halide, since potassium nitrite is strong electropositive in nature, that's why negative charge appears on oxygen, and this oxygen is more electronegative than nitrogen and higher electron density is present due to negative charge. It directly get attached with the alkyl and forms alkyl nitrite. Like CH3Cl reacts with KNO2 formation of CH3NO2 with KCl. This is methyl nitrite. Next, if C2H5Cl reacts, C2H5Cl reacts with potassium nitrite formation of C2H5 ONO with KCl ethyl nitrite. Whenever potassium nitrite reacts, nitrite are obtained. Next, reaction with silver nitrite. Reaction with silver nitrite AgNO2. When alkyl halide reacts with silver nitrite AgNO2, nitro product are obtained with elimination of AgX. Here alkyl attached with nitrogen directly, not with the oxygen. So nitro product are obtained, nitroalkane, like CH3Cl reacts with AgNO2, CH3NO2, nitromethane with AgCl. If C2H5Cl reacts with silver nitrite AgNO2, formation of C2H5NO2 with AgCl. This is nitromethane, this is nitroethane. So question arises, why there is formation of nitro derivative when silver nitrite reacts with alkyl halides? The same answer, since AgNO2 is covalent in nature. So only nitrogen is free due to availability of lone pair of electrons, higher electron density. That's why this nitrogen makes a bond with alkyl and nitro derivative is obtained. In silver nitrite, it is covalent in nature and nitrogen is free to make a bond with alkyl due to higher electron density. That's why silver nitride results nitro products, while in the case of potassium nitride, since it is strong electropositive in nature, potassium, and strong ionic nature of the compound, That's why oxygen is more electronegative than nitrogen and get attached with the alkyl, carbon of alkyl. पोटेशियम नाइट्राइट और सिल्वर नाइट्राइट के प्रोडक्ट्स में ये डिफरेंस है कि पोटेशियम नाइट्राइट में नाइट्राइट डेरिवेटिव वाइल सिल्वर नाइट्राइट में नाइट्रो डेरिवेटिव ऑब्टेन्ड होंगे. नेक्स्ट, रिएक्शन विद अमोनिया. Reaction with ammonia. When alkyl halide reacts with ammonia, ammonia can be written like this. Then HX eliminated, formation of primary amine. Formation of primary amine takes place with elimination of HX. For example, C2H5Cl reacts with ammonia, then formation of C2H5NH2. C2H5NH2 with elimination of HCl. But when excess of alkyl halide is taken, then all the hydrogen of ammonia are substituted one after one and a group of a mixture of products are obtained, like in first step this, in second this C2H5NH2 due to excess of alkyl halide reacts again with primary amine with elimination of HCl. So here C2H5NH, C2H5 with elimination of HCl. This is secondary amine. In first step primary amine, in second step secondary amine. Now in third, this C2H5 whole twice NH, that is this secondary amine, reacts with again C2H5Cl and this hydrogen is displaced and formation of C2H5 whole thrice N with elimination of HCl, and this is tertiary amine. Tertiary amine is formed. Next, reaction again continued. Due to availability of this lone pair of electron, this C2H5 whole thrice C2H5 whole thrice N, due to availability of lone pair of electrons, again reacts with alkyl halide and results C2H5 whole 4N plus Cl minus. This is ethyl amine, aminoethane. This is N-ethyl ethanamine. This is N-diethyl ethanamine, and this is tetraethyl ammonium chloride. So a mixture of product are obtained when ammonia reacts with excess of alkyl halide. Mixture of amines are obtained. Primary, secondary, tertiary and quaternary amines are obtained. Next is formation of Grignard reagent. When alkyl halide reacts with magnesium Mg metal, this alkyl halide when reacts with magnesium, formation of RMgX takes place. This RMgX is called Grignards reagent. Very important compound, Grignards reagent. This is a category of organometallic compound. This why? Because here one metal carbon bond is present. Due to presence of one metal carbon bond, It is organometallic compound and it is Grignard reagent because its formula is RMgX, where R is CS3, C2H5, C6H5, etc. Aryl may be there, and halide, chlorine, bromine, iodine. So real example will be C2H5Cl reacts with magnesium, formation of C2H5MgCl. This is called ethyl magnesium chloride. Formation of Grignard with the help of alkyl halides. With the help of alkyl halides. Next is reaction with metals. In reaction with metals, one is magnesium, another is sodium. A reaction with sodium. When alkyl halide reacts with sodium, what the products are obtained? Rx reacts with sodium. Two molecules of alkyl halides in ether medium. In ether medium, elimination of NaX, 2 sodium, 2 NaX, formation of R single bond R. What is R single bond R? This is alkane. This is alkane. When alkyl halide reacts with sodium metal, results alkane formation in ether medium, and reaction is called as Wurts reaction. This reaction is called Wurts reaction when alkyl halides reacts with sodium metal in ether medium, gives alkanes of higher carbons than parent alkyl halides, and this reaction is called Wurts reaction. It is used in conversion to find out higher number of compounds. So real example will be of Wurts reaction like CH3Cl reacts with sodium CH3Cl, two molecules in ether medium. Now elimination of 2 NaCl, eliminated out, formation of CH3 single bond CH3 ethane. The parent alkyl halide was of 1 carbon and here alkane of just double 2 carbon ethane. Ethane is obtained. Taking next one, C2H5Cl under Wurts reaction reacts with sodium metal in ether medium. Then again elimination of NaCl with formation of C2H5 single bond C2H5, or we can note down CH3 CH2 CH2 CH3, butane is formed, normal butane. So 2 carbon containing alkyl halides under Wurts reaction gives 4 carbon containing alkanes. In Wurts reaction, if we take different alkyl halides, here we have discussed about the identical types of alkyl halides. If we take different alkyl halides, then what the product will be obtained? Like CH3Cl reacts with sodium with C2H5Cl in ether medium. Then in Wurts reaction, the final product is CH3CH2CH3, that is propane, with elimination of NaCl, propane is formed. I repeat the reaction. When two different alkyl containing alkyl halides reacts with sodium metal in ether medium, then the product formed will not be alone because these molecules itself get reacts with sodium metal in the same medium and gives a mixture of alkanes like CH3Cl molecules also reacts with sodium metal in the same ether medium and gives C2H6 as the product, and in next C2H5Cl also reacts in this mixture and gives C4H10 as main product. So a mixture of products are obtained when two different alkyl halides undergoes Wurts reaction. It results a mixture of products. Next, if one alkyl and one aryl halide reacts, alkyl halides reacts with aryl halide with sodium in ether medium, then reaction is called Wurts fitting reaction. It's called Wurts fitting reaction. Not only Wurts, it's called Wurts fitting reaction when alkyl halide and aryl halide reacts with sodium in ether medium. Then Wurts reaction is called Wurts fitting reaction due to presence of alkyl and aryl group. What the next product will be obtained? Now see the real example. CH3Cl reacts with sodium metal and chlorobenzene. C6H5Cl aryl chloride, aryl halide, alkyl halide in ether medium. Elimination of same NaCl and formation of C6H5CH3. This is called toluene. Toluene is formed as a product under Wurts fitting reaction when one alkyl halide reacts with another aryl halide in sodium ether medium, then product form contains aryl and alkyl group, and this aryl and alkyl group, and this reaction is termed as Wurts fitting reaction. Next is, if two aryl halides, if only aryl halide undergoes reaction with sodium metal in ether medium, then the product obtained and reaction is called only fitting reaction. Only fitting reaction. So what it means? When two alkyl halides identical or unidentical reacts, Wurts reaction. When one alkyl and one aryl halide reacts with sodium metal, Wurts fitting reaction. And when two aryl halide reacts with sodium, fitting reaction is considered like C6H5Cl reacts with sodium metal with C6H5Cl in ether medium, formation of C6H5 single bond C6H5 with 2 NaCl like this. Called diphenyl. It's called diphenyl or phenylbenzene. Phenylbenzene. It's formed under fitting reaction. So Wurts reaction, Wurts fitting reaction, and fitting reaction. Next is when this alkyl halide reacts with zinc, it's called Frank-Land reaction. Frank-Land reaction with the same ether medium like CH3Cl reacts with zinc powder, two molecules of CS3Cl, ether medium, elimination of ZnCl2. ZnCl2 as a byproduct and alkane is formed. If we take zinc metal in place of sodium, so reaction will be termed as Frank-Land reaction, not Wurts. Frank-Land reaction when zinc is used in place of sodium. So this is the basic difference between Frank-Land and Wurts reaction. And what about the Wurts fitting and fitting reaction? We have discussed already. So this is all about in chemical properties of haloalkanes. So students, it will be continued in next segment. Till then, thank you everybody.